Welcome, everyone. Good day to you. Good day to you from wherever you're watching in the world. I put in the chat to let us know where you're watching from. 𝗙𝗺 is joining us from Toronto and is our keynote speaker today. So welcome. We've got a really packed show for you today. I'm Nancy Regan, and I'm joined by Graham Stephen, Chris James, and 𝗙𝗺_SIFONTE. Mark Horton is not with us, but he'll be with us next time. We are the IRCC, the International Reliability Centered Maintenance Certification Committee, and we're dedicated to helping you get the most out of your RCM analyses by making sure your team understands true RCM principles. So today we've got 𝗙𝗺 headlining for us. And if you are from the United States and you know baseball, I grew up in Boston where baseball was a religion. We've got a real switch hitter up today. 𝗙𝗺 is going to present common FMEA, failure modes and effects analysis pitfalls that could be increasing your costs and compromising your safety. And for our first 30 minutes, 𝗙𝗺 is going to present in English, and then he's going to switch it up and he's going to present in Spanish. So 𝗙𝗺 has been in reliability since 1993. He's been doing RCM for over 20 years. He's co-author of the book RCM Re-Engineered, and we are delighted to have you today, 𝗙𝗺. So I'm going to turn it over to you, 𝗙𝗺, where you're going to talk about the common FMEA pitfalls.
Thank you very much, Nancy.
Yep, take it away. And I think you have to share your screen again, 𝗙𝗺.
Okay, yes, I'll do so.
And while you're getting that sorted out,
now.
I'm going to see where everyone is watching from. Let's see. Okay, Toronto, Williamsburg, Virginia. Welcome, Lucas. Okay, Martins, or is it Martins? I'm not sure. From Nigeria. Wow. Thank you for joining us. Hello, Armand. Welcome, everyone. Okay, 𝗙𝗺, it is all you.
Thank you very much, Nancy. I'm really delighted to speak about FMEA, which is basically the base of RCM. So I'll speak about how to develop an effective FMEA for RCM. And there are a couple of pitfalls that Nancy already introduced me. I will speak about, and the thing is that we want you to avoid it, to do RCM the right way and to take the most out of it. So to start, let me introduce what RCM is about. Let me speak about its definition. RCM is a systematic process to determine what must be done to keep assets doing what owners need them to do in their current operating context. So there are key words here or phrases that we need to be aware about. One is the operating context, which is the ambient in which the asset is to be operated at. The owners, we need to understand the owners, what the owners want from the assets, and also what must be done. Many people think that RCM is only for producing maintenance tasks, but it renders more than that. And what must be done entails tasks, maintenance tasks, and also redesign tasks and other things. So RCM is intended for high criticality assets, and the actions or the outcomes of RCM are prioritized based on risk, the risk that those the failures of those assets pose to the organization. The RCM process is about answering 7 questions in order, and we will stress all the attention in the first 4 questions, which is the FMEA. Question number 1 is about the functions and the operating context. Question number 2 is about the functional failures. Then question number 3 is about the failure events, which we call failure modes, and then failure effects. So we will be tackling these 4 questions in order, and we'll speak about the most common pitfalls and how they can affect the outcome of RCM or the benefits that we get out of an RCM analysis. Okay, let's start with question number 1. And by the way, while doing my speech, my talk, I will be referencing the 𝗙 JA 1011 standard, which is the standard for doing RCM. So I will be referencing it as much as I can. So all my thoughts or my speech be based on the fundamentals of RCM. So question number one is, what are the functions of the asset and the desired standards of performance of that asset in its present operating context? Look that I have highlighted here a couple of concepts: operating context, desired standards of performance, and functions, and I will cover this in the presentation ahead. So let's say what the standard, let's see what the standard says about the operating context. The operating context of the asset shall be defined. And the standard clarifies that before answering question number one, which is about the defining the functions, we need to have a clear understanding of the operating context. Let me see if I can highlight that using a laser pointer. Okay, in here we see that inside 𝗖𝗺 1012 6.1, the standard says that before we attempt to answer the question one about the function, we need to establish an operating context. So it is said in the standard, which is the most common pitfall about the operating context, is it is not doing it at all. Many people go straight to answering question number one about the functions and forget that we need to establish an operating context. So not filling the blanks, just leaving it alone, not doing the operating context is the most common pitfall that we see. And this is hindering you from getting the most out the most out of your RCM analysis. So let's see what we should do. Okay, the right way to do that is just to follow the recommendations of the standard about the operating context. There are a couple of aspects that we need to address in the operating context, ranging from a detailed description of the system, going up to the company in which this asset belongs to, which is the, just a background on it, then going to the system boundaries, what we are going to analyze, what is going to be out of the analysis, the type of process, quality, environmental, safety, and standards, the theater of operations, etc. There are a couple of aspects that we need to understand very well, which establish the basis for the analysis. We also have to take into consideration protected devices and so forth. So the facilitator needs to be aware of the operational context, refine it with the team, and then proceed to answer question number one on the functions based on that operating context. Okay, what else? Question one is also about functions, defining functions. And the standard says that all the functions of the asset shall be identified, not only primary functions, but all the functions, all primary, secondary, and the functions also of protected devices are really important to be defined. All function statements shall contain a verb, an object, and a performance standard. That is what the standard says, what the 𝗖𝗺 1011 for 5.1.3 says. And the standard should be quantified whenever possible. So let's see what are the most common pitfalls on defining functions. So remember that we have primary functions, we have secondary functions, and also functions of the protected devices that we call hidden functions, which is hidden functions are those functions that are not apparent, whose failures are not apparent to operators under normal circumstances. So this is what a wrong FMEA looks like with regards to the functions. What are the most common pitfalls? Incomplete primary function statement, with missing standard of performance. In here, we see that it says to circulate chilled water, but it doesn't say, for example, what is the how much water we are circulating. It doesn't speak about any performance standard. There are secondary functions here that are missing, and also we don't define any hidden function or any protected device functions. So this is sometimes streamlined processes, so-called streamlined RCM processes. They rule out important information that will hinder obtaining the most out of an RCM analysis. What is the right approach? So you should use a verb to circulate, a performance standard. This is the desired performance levels by the owner of the asset, and an object. So this is the right way to produce functions, and see that we are considering here both primary and secondary functions, and also we are including functions of the protected devices to be able to stop the pump in case of an overload. This is an example of a hidden function, and this is the way that we comply with the standard when we are defining functions. So let's go ahead now with question number 2. This is about the functional failures. In what ways it can fail to fulfill its functions. We call that functional failures. Let's review again what the standard says about the functional failures. The standard says that all the failed states shall be identified. So we need to understand which are the possible ways in which the asset will not conform to the function. So one of the most common pitfalls here is like defining functional failures in terms of the asset parts or asset components. And we should avoid doing that, and we should rather define failure in terms of the loss of a specific function. So this is 𝗙𝗺 1012. Part 7 says that it is more accurate to define failure in terms of the loss of a function. There are basically 2 types of functional failures, or states, 2 types of states of the failure. One is total, and the second one is a partial failure. So we need to be sure that we include both of these states of the failure in our FMEA. As you see here, these are common pitfalls. Unable to circulate chilled water, okay? Though it is correct, it is including here in this FMEA, we are including only the total fail state. There is no a partial fail state here, functional failure, so we are not complying with that part. Here you see that we have a statement saying jammed impeller, broken gasket. Statement like that, referring directly to components, are not considered correct functional failure statements. So these are the most common pitfalls when defining functional failures. The right way to do it is the one in which you identify both the total and the partial functional states. Here you see that we are unable to supply, the pump is unable to supply the minimum needed, which is 30 GPM. And down here, you see that it is not able to supply at all water. So we are here defining both partial and total fail states. And we are also not avoiding using physical failures instead of the loss of the function, which is the right way to define function. So if you do it like this, you will be complying with the standard, and you will have no problem defining functional failures. So functional failures and functions are easy to define. Where we see the most problem in FMEA is when we go to the failure modes. So let's go now to this question number 3. And here is where we have identified a lot of trouble with our fellows that doing RCM. Failure modes, let's go there. Let's see what the standard says. Let's review. The standard is our guide. So if any person is doing RCM, that person should follow the standard, should answer the questions the way the standards recommend them, and also do all the questions in order. What about the failure mode? The standard says that all failure modes likely to cause each function of failure shall be defined. So here is the part of the FMEA where we are looking for events, failure events. And let's see how the standard sheds light on how to define them. So the standard says that the failure mode is a single event causing a functional failure. But here we're triggering a concept that is the root cause. How deep do we go to find root causes? So the standard says that you should consider these events that are happening, the ones being prevented by the PM program, and those that are likely to happen under the current operating context. With regards to the depth that we are going to analyze the causes, the standard says that the description of a failure mode should contain enough but not excessive detail for a proper failure consequence management policy to be selected. And maybe this definition could be too broad for many people. There are a couple of concepts here, and I will try to help you define it in other terms so you can understand how to develop, how to produce correct failure modes. To start, avoid using these verbs: fails, breaks, malfunctions. So a correct failure mode statement shouldn't use these words. Instead of saying fails, tell us how it failed. If you answer how it fails, how it breaks, how it malfunctions, then we will be doing a better job when designing, when mentioning failure modes, when producing failure modes. The standard says that failure modes shall be identified at the level of causation that makes it possible to identify an appropriate failure management policy. RCM and FMEA for RCM are risk management tools, are risk management are intended to identify risks, and failure modes are really risk events. So, and we should define them in such a way that the level of causation lets us later define a failure consequence management policy or a task to reduce the failure consequences to tolerable levels. So what kind of failure modes we have to consider according to the standard? The standard says, JA 10-12, 3.3, 3.5, that we should consider deterioration, design defects, and also human errors. By deterioration, we need a failure mechanism: fatigue, corrosion, abrasion, erosion, degradation, etc. These design flaws that we are dealing with day in and day out during the operational stage of the assets, we need to address them. They were done during the construction phase, but we have to tackle them. We have to deal with them day in and day out. And also human errors like operational errors, assembly errors, etc. You may have the best task in the world, developed by the best reliability engineer, and if we don't, I mean, to deal with natural deterioration. But if we don't deal with human errors, we will never be solving those problems. And design flaws, of course. So let's see how we see while reviewing some RCM analysis, what we find commonly. So here you have statements like broken filter, valve malfunction, failed impeller, broken coupling, etc., etc. So these statements are vague, are not good enough to find a proper failure consequence management policies. And what are the mistakes here? Usage of the non-recommended verbs. Instead, you have to say how it breaks, right? No apparent causation. Sometimes people concentrate just on the natural deterioration, ruling out design flaws, for example, and not possible design of flaws here, and human error also overlooked. So these are the most common pitfalls while defining failure modes. An important thing about the definition of a failure mode is that later on, the tasks that we find with the decision diagram are supposed to target these failure modes. And if the failure modes is wrongly defined, we wouldn't be able to find the right task. So here, you see here that we have the definition of failure modes. I will give you a kind of a tip, and you will never miss when trying to define a failure mode. A failure mode is a combination of a failure mechanism and a failure cause. In the failure mode statement, you should establish how the failure event could happen through a failure mechanism and why it could happen, and evaluate all possible scenarios under the current operating context. If you have any doubt about failure mechanism, you should consult ISO 14224. There is a table there, and you will see the most common failure mechanisms. There are mechanical mechanisms, there are electrical mechanisms, material deterioration type of mechanisms. Review that. And also there is another table for common failure causes. Okay, but the key here is to establish clearly the failure mechanism and the possible failure cause for it. If you do that, you will never miss your failure modes. So you will be always defining correct failure modes. This is question number 3. Now we go to question number 4. What happens when each failure occurs? That is the so-called failure effects. This is where here is where we, let's say that we understand the impact that those failure events are having on company objectives, right? So failure effects shall describe, this is what the standard says, what will happen if no specific task is done to anticipate, prevent, or detect a failure. What it does here, what we do here is that we describe what will happen if a failure were to occur. So we need to let the failure modes occur in our minds, and then we quantify that impact that failure are having on objectives. So we need to evidence that statement with all the information that we have on the asset. Let me go back, things like safety, environmental, operational, and physical impacts that those failure modes have or may have on our operations have to be taken into account here. We need to have data or information to support that evaluation. Because here is basically we are saying how bad things are going to be if that a failure mode is to occur. So let's see an example here. So let's suppose that we have a clogged suction filter due to normal wear and tear. This is the failure mechanism, and this is the failure cause. And we then write down a failure effect statement like this one. Process stops, okay, that happens. This is considered very important for production. The repair is of low cost. This statement has a good intention, which is to establish what happens when the failure occurs, but there is some other information missing in here. And if we were to do it more completely, we should speak about how is the detection, how do we detect that failure mode, how the safety of people around the asset is affected, how the environment is affected, how production is affected. We should be speak with more detail about it. How, if there are physical damages, what kind of physical damage we're talking about, costs, and also likelihood of the failure, secondary damage, etc. In the standard, there are some guide questions, guide bullets that if we will, that will show us how to do an effective statement for failure effects. So remember that this information is the one that you are using later on for the failure consequence management policies. If you are to justify them, this information is going to back you up. See here that all aspects of the failure effects required by SAE J8 and 11 are considered in this statement. Risks, safety and environmental, etc. risks, and cost are analyzed here. And we have, if we use other approaches, we can even do an RPM analysis for prioritizing later on the task. So this is it. We have already spoken about question 1 through question 4, the common pitfalls about it. And I will be glad to have some questions and to answer them for you guys. And feel free to ask the questions. And I'm here with other 3 colleagues. If there is a very tricky question for me, what I'll do is, I'm a team player. I will pass the buck to another. No, I'm joking. I will answer it. I'm going to answer it.
Okay, thank you, Jesus. While we're waiting to see if anyone has any questions, Lucas early on put in the chat a very important element, and that I believe is when you were talking about functions, which is an often overlooked part of the process. A lot of people write functions just as a matter of course, because it might feel like it's not a very important topic, but it can be one of the most important steps.
Yes, fully agree with you, Nancy, and also the operating context. There are some trends nowadays in which people do RCM to similar equipment just at once. And they say, we can do RCM for 2,000 similar pumps. And we can do it at once because we have this software that do miracles for us. And all of them will have the same, for example, a maintenance program. But where are the operating contexts, taken care of? We have to take care of that operating context. We may be overdoing, and by overdoing maintenance, we will be inducing failures also.
Yes, exactly. And I was reminded about how important functions are the other day. So I get into my 2014 Subaru Forester, and when you think about an air conditioner, you might just write a quick failure effect, to say, to maintain temperature in the car between a certain temperature. So I go to turn on my air conditioner, and I'm in Huntsville, Alabama. So at this time of year, it's very hot. So I turn on my air conditioner, nothing happens. So I turn the fan up to level 2, nothing happens. Level 3, nothing happens. All of a sudden I turn the fan on level 4 and bam, I've got all this cold air. So my air conditioner works, but it doesn't work the way I want it to, because now I have to drive with it blasting on high. Then when I get cold, I have to turn it off. So I have to keep doing that on and off. Now, that's a very simple example. But when we're talking about complex equipment within our organizations, how well something works, if it's not working like we need it to, that can adversely affect operations, production. It could have safety consequences. So it's very important to think about exactly what we need something to do.
Yes, and also the owner of the asset. You may be expecting some temperature if you're in your room, and your partner may be expecting another, and which is the owner of the asset. You know, the functional failure will depend on the expectations of that owner of the asset. And many people have the wrong idea that we need to consider just the design capabilities of the asset. And the result of an analysis which considers just the design capabilities is over maintenance. So we will be recommending a lot of maintenance tasks that are not needed. And Nancy, I have a saying and that I always share with my colleagues when doing classes, is that maintenance is good. Yes, maintenance is good. And I compare maintenance with pills. Pills are good if you need them. If you take a pill that you don't need, you will have side effects that are not wanted. So maintenance tasks are the same. They are good when they are needed. But if you don't need them, you will be dealing with an equipment, you will be stopping an equipment which doesn't need that pill, doesn't need that task, and you will be inducing failures. So that's why the defining functions and the operating context is so important when doing an RCM analysis. That's the basis for the analysis.
I love that analogy, Jesus. That's awesome. Okay, we've got a question for you, Jesus, from Martins. He wants to know, he says, I understand that RCM requires some investment in time and money and effort to carry out. He wants to know, how long should an effective RCM take, and how soon can the benefits be seen? That's a loaded question, Jesus.
Oh, yes, but that is most common. That question is more common than we might think. So,
yeah, it's an important one.
Yeah, oh, sure it is. So let's start with the very basics. We don't do RCM across the board to all the items, to all the assets. We should have an idea of the criticality of our assets. And I like the 𝗖𝗺 standard for the pharmaceutical. The 𝗖𝗺 standard says that you do RCM on criticality level 1 and 2 out of 5. So for items that are very, very critical, extremely critical, and importantly critical, you do RCM to those. That may maybe comprise just 20% or 30% of your asset portfolio. That should start. So you don't have to apply RCM to every asset. Okay, how long the asset analysis will take? That depends on 2 factors, or 3. Let's start with the first one, which is how many failure modes we have there. So that doesn't depend even on the size of the asset. You may have a very big asset, but with a few components. If you have many different components, there will be a lot of failure modes, and your analysis will take more time. The second concept, or the second aspect, is the facilitator. If you have a very knowledgeable facilitator, and the team the facilitator is working with, assuming that we are using a multidisciplinary approach, if the team is trained and the facilitator is experienced, that person will do the analysis faster than a newly hired facilitator. And when people say, but how fast? How much faster? About 5 times faster. What a experienced facilitator can do in 1 day can take a week for a new facilitator with a new team. So these are the 2 factors. Okay, with regards to the benefits, okay, there are, on my view, two types of benefits by doing RCM. The ones that you get immediately. Which are the ones you get immediately? Well, you will get a reduced amount of work to do. When you do RCM to assets that are subjected to OEM tasks, you will experience a great reduction, in time. And if we remember the 747 project, in the 747 project, which is the airplane, 747, the amount of tasks were reduced by 85%. So that's a lot. And my experience, and I'm sure that my colleagues' experience here is the same, that if you apply RCM to an asset that already is undergoing an OEM type of maintenance plan, the amount of man hours of your PM program is going to decrease from 40 to 70%, something like that. So that is a benefit. You will be applying more intelligent tasks requiring less time. You will be applying less intrusive type of tasks. There are other benefits that you will experience at the long run, which is the economical ones. I remember a project that we did like 10 years ago, and the customer by himself kept track of the savings, and after a year called us and reported his savings. So at the long run, they had a reduced failure cost. So they were not a production company; they were a water treatment plant. So it was public service. So they don't sell anything, like they didn't expect any earnings, but they reduced a lot the cost and the man hours, and that was for corrective tasks, and that was seen 1 year on the run. So these type of benefits, ROI, you wouldn't see them immediately. So maybe in a year, in a couple of 2 or 3 years, you will be seeing those type of benefits building up. I was asking for that. Yeah. Any of my colleagues?
Yeah, sorry, Jesus, I don't want to butt into your presentation, but it's possible also that you might see some benefits quite quickly, because if for example, people don't understand the functions, or they don't understand the context, or haven't considered the context, then there might be quite a lot of learning that takes place.
Oh, yeah.
when they do the RCM. And if that, because there were the softer benefits from RCM as well, which ultimately translates into harder benefits like better cost and reliability. But if people learn about the equipment, then those benefits hopefully can start to flow straight away, really. And obviously, if you don't implement your improved maintenance, you're not going to get those benefits. But if you do it well and you learn things, you can start to get some benefits, some spin-offs straight away as well, I think.
Excellent. And Chris, and now you're triggering me other benefits that I have here on my mind. For example, motivation.
Yeah.
You are building better teamwork. So out of the sudden, I've been doing, for example, a month ago, I was at a US pharma company doing an RCM analysis, and I asked them, how often do you meet? And they say, people from production, quality, different departments say, almost never. When there is a problem, we meet up. So in RCM, they are all together for a week, for 2 weeks, for very periodically together doing the analysis, and they exchange knowledge. There is a knowledge exchange, and run practices are discussed. And sometimes people from production say, everything is good until maintenance do the PM. And then we have the premature failures. And people from maintenance says, yes, but remember that when you operate it wrongly, it also breaks. And they bring those things to the table and are discussed, and the causes are better understood. So RCM is a teamwork type of methodology, and also builds better teams. That is a soft type of benefit that we get immediately.
Okay, Jesus, we have another question from from Martins. Why do companies not do RCM but want to optimize production without realizing RCM plays a big role to play? Big question. Yep.
Okay, that question has to do with culture. So if RCM is not going to work if it is not part of a bigger strategy. So if the organization has the vision, has the asset management and risk management vision, by default, it's going to use RCM and everybody is going to be aligned. So it is more about culture. It is more about what the operator management understands, that what the reliability engineers can do or the technicians can do. The most successful projects that we have worked with have started at the corporation level. So at the corporate offices, where people develop the mission of the company. They develop all these strategies, of course, with the help of the people down there. But when that operating management understands the need for asset management, the need for risk management, RCM is gonna appear, and it's gonna be done. But if the maintenance, people are trying to push RCM on their own without the backup of the other departments or upper management, it's difficult that it is going to succeed.
Yep. And we've got a couple of comments, Jesus, that I'd like to highlight. Andy says, when you were talking about functions and operating context, he had a context issue on two similar pumps with a copy and paste proactive maintenance. One pumped ambient water, the other vegetable oil at 180 degrees C. Bearings failed in hot oil pump as wrong spec oil was being used. So that's an excellent example about why it's so important.
Yeah, it totally aligned, Andy, totally aligned. And there's a live example, and what we are talking about. So I've seen these days people putting some great examples. There was also an example of an air conditioner in the outdoors. And one was in a town where there is a lot of dust. And the other one is in a clean town. OEM tells you change the filters every this amount of time. And even for the same corporation in different locations. And the ones from the corporation A said, we can let those runs for months. And we don't have to follow the OEM because it says change every 3 months, and we can have them running for a year. The other folks from the dusty environment said we need to change them every month. So the operational context is everything. So
okay, we have another comment. This one is from Carlo. There's also a tremendous opportunity for others to have a say in innovative approaches that may resolve the situation that arise. In other words, they have skin in the game. I think Carlo's talking about when you were talking about a facilitated working group approach. And finally, people being allowed to gather with a formal process so that their voice is heard.
Yeah, thank you for your comment, Carlo. I wonder if you're going to stay for the Spanish. Carlo speaks Italian, Spanish, and many languages. So maybe he can if he's not bored already, he can see my Spanish talk.
It would be hard to believe anyone could be bored. Okay, we've got another comment from Lee. It's a long one, Jesus. So I'm going to put it up here. It's
okay.
Be good discussion. Lee says it's interesting when you see the effects of getting something not quite right has further in the process, like creating a function without a performance standard, for example, means that you can only define total functional failure and so on. Yes, it limits how your working groups think, because then they're only thinking total failure. Another example is FMEA that captures failure effects before failure modes. Yep, just like in MSG3 where they're transposed, because that could impact the level of detail that's captured in failure effects.
I thank you very much, Lee, for your comment. It's really a good one. And I'll tell people, the standard side JN 1011 just do what it says. Don't mess with it. Just go in order, answer the question in orders. There are tips for defining, every step, every question to answer, every question. Don't go around it. Just follow it, and you will get good results. And of course, everything is not in the standard, but the guidance is there in the standard. There are other international standards that we refer to when we want to define things like failure modes, failure mechanisms, etc., and other things. But follow, all the frame is there. The framework is there in the standard. And people sometimes, especially in a streamlined processes, they rule out parts of the standard. You can't pretend to get all the benefits if you rule out some part of the standards. Like very common in Nancy Graham and Chris is not defining, for example, secondary functions. People think that secondary functions are not as critical as primary functions. They might be even more critical. They have to do with regulations. They have to do with other than the main thing that the asset has to do. Things like not ruling out the protected devices. So we'll leave that for later, and we never do it. Protected devices, failures are hidden failures most of the time, and they are associated to catastrophic events. So you are leaving out, the analysis of possible catastrophic events, and that is, to me, that's not acceptable.
Yep. Okay. Any other thoughts or comments from anyone? You can put it in the chat. And I don't know, Graham or Chris, if you have any other final thoughts before Jesus starts to get teed up to present in Spanish.
I'm left-handed now. I'll be right-handed.
Yes.
The only other thing I'd add, I'd echo what you said, Jesus, about failure modes. John Mowbray used to say that they were the currency in physical asset management. It's the failure modes that you maintain, and so it's important that they are defined properly. Because that's what you're managing, and it's important therefore that you describe these failure modes in an acceptable level of detail, because that will drive that your maintenance deals with causes rather than effects.
Yeah.
So a very important part of the FMEA really is the failure mode.
Chris, that's why an experienced facilitator is so important in an RCM analysis. And there is a direct connection of question 3, which is failure modes, to questions 6 and 7, which is the ones where you define the failure consequence management policies, because these policies are targeting failure causes. And if we have vague failure causes, we will have wrong policies, or we wouldn't be able to define policies correctly. If you say broken coupling, and you don't understand how it breaks, then what would you do? Replace the coupling no matter what. And if the problem is not the coupling, maybe it's the design of it, maybe it is the operation of it. So you better understand how, of course, things also degrade, with time. Now, I'm not saying that, but we have to tackle that, the natural deterioration and also other possible causes.
All right. Well, Jesus. Do you have something, Graham?
No, thank you. That's very informative. Well, the only thing I was going to say, and I was looking around for it myself, is that a couple of weeks ago when I did the RCM and electronics thing, I put up a slide which showed about a dozen submarine systems where we showed savings in effort on issued maintenance from anywhere from 40% up to 88%. It's spectacular. So yeah, John's put it in his book, and I'd bear that out absolutely.
Perfect.
Excellent. Okay, so while Jesus gets ready, switch it up and present in Spanish, I would just like to briefly show, if you are interested, you can visit our website. It's 𝗙𝗺𝗺𝗀𝗡𝗃.org. And as I mentioned in the beginning, we as the IRCC, we're dedicated to helping people and making sure that they're applying RCM correctly. You know, we don't care how you've learned. We are interested in making sure that you understand the principles and that you apply it properly. So we are an independent certifying board. Now, we've been talking a lot about today, you know, why don't more organizations do RCM? I think very often RCM gets a bad rap, that it's too expensive, it takes too long, you don't get the results you need. And one of the biggest causes, we've been talking about failure causes today, one of the biggest causes is that RCM isn't applied correctly, or it's applied by people who are not trained properly. So it just naturally drags out the process and some of the steps aren't done properly. So one way you can avoid that and stand out from the rest is to get your RCM certification. Level 1 is ready. You can go to rcmcertification.org and you can read about that, and you can read about what it takes to get your level 1 certification. We are going to, and if you, we're going to be doing lives at least twice a month. If you want to be notified when we're going to be doing our next live and to get replays sent right to your inbox, go to rcmcertification.org/subscribe. Just enter your name and your email address and we'll keep you updated. We won't spam you, promise. We'll only send you really cool reliability-centered maintenance information. Okay, so just to mention our next live, that's going to be happening on Wednesday, May 19th at 9 a.m. Central. I'll be talking about common mistakes when identifying failure modes. And Chris reminded us what John Mowbray used to say about failure modes, that it's the currency of physical asset management. So if you get your failure mode identification wrong, it can make everything really just kind of go sour in your RCM analysis or not get exactly what you need from it. So please tune in next week for that. And let me just look in the comments one more time before you start in Spanish. Okay, Martins wants to say thank you. Thank you, Jesus, for an excellent presentation. Thank you for joining us, Martins. Thank you, Carlo. All right, awesome. Okay, so if there is nothing else, let me remove this. Jesus, I'm going to turn it over to you. You can share your screen again. And I'm going to turn it over to you. Jesus is now going to present the same information, but in Spanish.
All right. Let's see if I'm able to. Okay, I think that I have to go back to the presentation and I won't be seeing you guys. Ok, ahora cambiamos a español. Ahora, bateando a la derecha. Desarrollo de un FMEA eficaz para RCM. Vamos a discutir los errores más comunes que se cometen al hacer un FMEA para RCM y vamos a tratar de también vamos a presentar cuáles serían las formas de evitar esos errores. Así que, bueno, ya me presentó Nancy, soy Jesús Cifonte, parte del IRCC Committee. ¿Okay? Vamos a hablar de la norma 𝗙İ𝗺𝗃_1011 y vamos a definir el proceso de RCM. De hecho, durante mi plática voy a estar haciendo referencia siempre a la norma 𝗙İ𝗺𝗃_1011. Todas mis opiniones, todas mis declaraciones van a estar respaldadas por alguna parte de la norma y yo voy a hacer referencia en su momento. ¿Okay? El proceso de RCM es uno sistemático en el que se determina qué hacer para que los activos hagan lo que su dueño necesita bajo su actual contexto operativo. RCM está destinado para activos de alta criticidad, high criticality. So aquí vamos a estar aplicando RCM no a todos los equipos de la planta, sino a aquellos que por los riesgos que representan para la empresa se le necesita que se le aplique pues una metodología que sea, digamos, completa para determinar esos riesgos. Y vamos a estar priorizando las acciones ¿verdad? Los resultados de RCM. Las tareas se van a priorizar de acuerdo a los riesgos. En este caso, aquí tenemos las 7 preguntas del RCM. Es un proceso en el cual se contestan 7 preguntas en orden. La primera pregunta es sobre las funciones, siguen fallas funcionales, modos de fallas, efectos de la falla, consecuencias, la pregunta número 5, ya las preguntas 6 y 7 son de las tareas, tareas proactivas y acciones por defecto. En esta presentación voy a estar evaluando, vamos a estar mirando las primeras 4 preguntas, que es donde aplica el FMEA. ¿Okay? Así que vamos a estar viendo funciones, fallas funcionales, modos de fallas y efectos de la falla. La importancia del FMEA dentro del RCM, de hecho el RCM tiene básicamente 2 partes. La primera es el FMEA, donde se hace pues el análisis de riesgo, y luego viene la segunda parte, que es donde se toman decisiones, que son las preguntas 5, 6 y 7 basados en el FMEA. Así que mientras más correcto sea el FMEA, pues mejor serían las decisiones que tomamos hacia adelante. Primera pregunta: ¿cuáles son las funciones y los estándares de rendimiento deseados asociados de un activo en su contexto operativo actual? A esto le llamamos funciones. Y aquí vamos a hablar un poco sobre el concepto de contexto operativo y también vamos a hablar sobre las funciones y cuáles son los errores más comunes, las trampas más comunes cuando se aplican esto, ¿verdad? O cuando se definen durante el análisis de FMEA o el análisis de RCM. ¿Qué dice la norma? La norma dice lo siguiente: se definirá un contexto operativo del activo. No lo deja por ahí como opcional, sino que indica que debemos definir un contexto operativo en el que se expliquen las consecuencias, las circunstancias, perdón, en las que se va a utilizar el activo, aspectos regulatorios, de rendimiento, etcétera. Y miren el último inciso, en el que se indica que debe definirse claramente un contexto operativo antes de intentar responder a la pregunta número 1 del RCM. El error más común que se comete al definir, bueno, con el contexto operativo es que no se defina el contexto operativo. Si no hay información en el contexto operativo y se comienza a contestar la primera pregunta, pues básicamente estamos trabajando sin base. ¿Okay? Ese es el error más común. La forma correcta de elaborar un, digamos, contexto operativo es seguir las guías de la norma. Las guías de la norma nos indica que debemos hacer una descripción global de la empresa o del proceso más arriba, ¿verdad? El que el nuestro pertenece, el que estamos analizando, un análisis detallado del proceso, entender bien cuáles son las fronteras del análisis, determinar el tipo de proceso que tenemos, los estándares de calidad, de medio ambiente, de seguridad asociados a la operación y el mantenimiento de ese activo, el escenario de las operaciones, la intensidad de las operaciones y otros aspectos, ¿verdad? No puedo ir sobre todos los detalles, pero sí, el estándar nos ofrece unas guías para que nosotros elaboremos un buen contexto operativo. Tener en cuenta las funcionalidades protectivas de nuestro equipo es muy relevante para hacer un análisis de RCM. Una vez comprendido el contexto operativo, entonces pasamos a contestar la primera pregunta con respecto a las funciones. Dice la norma que se deben definir todas las funciones del activo. ¿Cuáles son todas? Funciones primarias, funciones secundarias y funciones ocultas del activo. Las funciones ocultas son aquellas que se relacionan con los dispositivos de protección, componentes redundantes o de monitoreo de condiciones. Las funciones, básicamente lo que el propietario quiere o necesita que haga el activo. Primarias son las principales, secundarias tienen que ver con otras cuestiones que el activo con las que debe cumplir mientras opera, con reglamentaciones, etcétera, y la función oculta es una cuya falla no es evidente. Vamos a ver cómo un ejemplo de los errores más comunes al definir funciones. Por ejemplo, aquí tenemos un sistema que debe circular aceite lubricante y la función está definida de manera muy vaga. Dice circular aceite lubricante, pues indica que sí es aceite, pero no sabemos cuánto aceite debe circularse, por cuánto tiempo, en qué sistema se va a circular. La declaración es incompleta y no tiene tampoco un estándar de rendimiento, y mucho menos cuantitativo. No tenemos funciones secundarias definidas y tampoco tenemos definición de funciones ocultas o de dispositivos de protección. Así que esto es muy común que suceda cuando se hace un FMEA. Y bueno, la forma correcta de hacer el FMEA es, primero, recuerde que después de haber hecho el contexto operativo, vamos a definir nuestras funciones, que nuestras funciones contengan un verbo, un estándar de rendimiento, siempre que sea posible, cuantitativo, y un objeto, ¿verdad? Entonces, aquí tenemos el cumplimiento con todo eso. De hecho, acá en la declaración se me quedó la parte de que dice de aceite lubricante grado BG32 a través de circuito. Eso se supone que estuviera aquí escrito, ¿verdad? Y vemos acá que tenemos una función secundaria y también una función oculta sobre una alarma, ¿verdad? Debe ser capaz de alarmar por baja presión de aceite. Esta declaración se conforma a lo que solicita el estándar 𝗙İ𝗺𝗀𝗀𝗀 con respecto a las funciones. Ahora sí apareció el resto de la declaración acá. Muy bien. Con relación a la pregunta número 2, fallas funcionales. ¿De qué manera puede incumplir sus funciones el activo? A eso le llamamos fallas funcionales. Recuerde que la falla funcional es la falla de una función, ¿ok? No es la falla de un componente físico. Tendemos a confundir un poco eso, ¿verdad? Se identificarán todos los estados de falla. Eso indica la norma. Una falla funcional no es otra cosa que un estado en que el activo no puede cumplir con su función a un nivel de rendimiento deseado. ¿Okay? Es más preciso definir una falla funcional en términos de la pérdida de la función que, digamos, en lugar de una falla física. Si la forma correcta de definirlo es a través de la pérdida de la función. Hay dos estados de la falla que la norma 𝗙İ𝗺𝗀𝗀𝗀 nos indica que debemos mencionar o tener en cuenta. Es el estado total, de falla total, y el estado parcial. Vamos a ver los errores más comunes que cometemos cuando se hace un FMEA para RCM, donde se incumple con la norma, con lo que requiere la norma. Aquí tenemos una función y circular un mínimo de aceite de 5 ppm, etcétera. Acá nos indica incapaz de circular aceite. Esa falla funcional, si bien está bien definida, digamos en este caso se toma en cuenta nada más la falla total. Sin embargo, no estamos mirando la falla parcial. En este caso tenemos una declaración que dice impulsor atascado, junta rota, instrumento roto. Estamos viendo que se están incluyendo fallas físicas de componentes en vez de la falla de la función, ¿verdad? Entonces son de los errores más comunes. Si vamos a ver cómo se subsanan estos errores, cómo evitamos estos errores, al definir la falla funcional, tenga en cuenta ambos estados, parcial y total. Aquí vemos claramente que se definen ambos estados. Aquí no circuló nada, este es el estado de la falla total. Acá soy incapaz de circular el mínimo requerido, por lo tanto, tengo ambos estados de la falla definido correctamente estamos viendo que no hay aquí fallos físicos, sino solamente fallos de la función. Así que de esta forma cumplimos con lo que recomienda el estándar. Y bueno, hasta aquí nuestro análisis de FMEA, pero nuestro análisis de RCM va correcto, acorde con el estándar. Vayamos a la pregunta número 3 ahora. Si ya definimos bien nuestra función, nuestras fallas funcionales, nos toca ahora definir los modos de falla. Este es un área, ¿verdad? Es una de las partes del RCM donde se cometen más errores. Nos indica la norma que todos los modos de falla que probablemente causen la falla funcional se deben identificar. ¿Okay? Así que en todos. Indica la norma que el modo de falla es un único evento y que debe describirse con suficiente detalle, pero no exceso de detalle, para que más tarde se puedan identificar tareas, ¿verdad? Tareas para la disminución de las consecuencias de la falla a niveles tolerables. ¿Qué tipos de modos de falla vamos a considerar? Aquellos que han sucedido, los que están siendo impedidos por el programa de preventivo que usted tenga hoy día, y aquellos modos de fallas que no han sucedido, pero son razonablemente posibles que sucedan. ¿Okay? Así que al definir un modo de falla, debemos tomar en cuenta que hay diferentes aspectos que la norma nos indica, ¿verdad?, que se consideren. Por ejemplo, deterioro, defectos de diseño y errores humanos. Así que seríamos como que un poco ingenuos si solamente nos enfocamos en los deterioros y el deterioro, digamos, natural, y pasamos por alto defectos de diseño y errores humanos que están afectando nuestras operaciones. En el deterioro, ¿qué se incluye? Pues deterioro natural, cosas así como fatiga, abrasión, erosión, desgaste, etcétera, de acuerdo pues a la misma norma. Defectos de diseño que fueron pasados por alto en la construcción y que nos están pegando hoy día, que nos están afectando hoy día durante la operación, y también errores humanos, temas de cómo se operan los equipos, como ensamblajes correctos, etcétera, tanto por el lado de operación como por el lado de mantenimiento, los vamos a tener en cuenta. Errores comunes. Recuerde, déjeme ver si lo escribí por acá. Hay unas palabritas que debemos evitar. Aquí debemos evitar las siguientes palabras. Evite los siguientes verbos, ¿verdad? Falla o fallar, ¿verdad? Que viene de fallar. Utilizar la palabra falla o la palabra fallar. Utilizar la palabra rotura, se rompe, no funciona, etcétera. Vamos a evitar de todas maneras de utilizar estas palabras o sus respectivos verbos, ¿verdad? En su forma de verbo. Errores comunes. Tenemos una falla funcional que es incapaz de circular aceite y utilizamos la palabra falla. Falla válvula, válvula defectuosa, falla el impulsor, coupling roto. Utilizar la palabra roto, rotura, se rompe. No cumple esa declaración con la norma 𝗙İ𝗺𝗃11. Rotura, daño, rotura, defectuoso. Debemos evitar a toda costa utilizar estas palabras. Más bien, aquí vemos que se están utilizando los verbos o las palabras no recomendadas. No hay causas aparentes. Se están tratando de mencionar o considerar solamente degradación. ¿Okay? Lo que tiene que ver con degradación. No hay consideración de diseños, no hay consideración de errores humanos. ¿Okay? Así que esta no es la forma correcta de hacer un FMEA, y nuestra misión en el IRCC es ayudarle para que usted pueda definir correctamente esos modos de falla. Por hacerlo, usted va a obtener mejores resultados del análisis de RCM, ya que podrá definir bien las tareas eventualmente. ¿Ok? Acá tenemos cuál es la forma correcta de hacerlo. Yo le voy a regalar una receta. La receta es la siguiente. Un modo de falla es igual a un mecanismo de falla más una causa de falla. Así que el modo de falla necesita indicar cómo la falla podría ocurrir. Como lo dije hace media hora atrás en inglés, ¿verdad? How the failure occurs, cómo la falla ocurre. Y también debe indicar por qué la falla podría ocurrir. Entonces, si nosotros podemos completar esta información, estamos definiendo modo de falla de forma correcta. Si usted tiene dudas de cuáles son los mecanismos de fallo comunes, consulte la norma 14224, ISO 14224, en la tabla B22. Ahí indica cuáles son los modos de falla, o más bien mecanismos de falla típicos. Hay mecanismos de falla eléctricos, mecánicos, de instrumentación, de influencia externa, de deterioro de material, etc. Así que esta es la forma correcta de definir los modos de falla. Una buena definición de un modo de falla es garantía de que es mejor garantía, vamos a decir así. Tenemos el 50% del camino ya recorrido para luego producir una buena tarea de mantenimiento o una buena recomendación que no necesariamente sea tarea de mantenimiento. ¿Qué sucede cuando cada falla ocurre? Estos son los efectos de la falla. Vamos a cuantificar, vamos a decir así, el impacto que estos eventos tienen sobre las metas de la organización. Y la norma nos da una guía de cómo hacerla. Así que los efectos de la falla van a describir lo que sucedería si no hacemos nada para evitar la falla. Si usted dijo, por ejemplo, que usted tiene un rodamiento amarrado, ¿verdad? Y usted explicó por qué, ¿verdad? Tiene rodamiento amarrado. ¿Qué sucede cuando ese evento ocurre? Si ese evento ocurriera, ¿qué es lo que sucede? Es exactamente lo que vamos a describir aquí. Perdón, en los efectos de la falla. Los efectos de la falla van a incluir información para apoyar lo que usted dice, ¿verdad? Y debe declarar evidencia de ocurrencia, cómo sabemos que ocurrió la falla, cómo se afecta la seguridad, el medio ambiente, las operaciones y qué daños físicos ocurren al momento de la falla. ¿Okay? Aquí tenemos una declaración de un efecto de la falla para esta combinación de modo y causa de falla, ¿verdad? Suponga que usted tiene un modo de falla que sea rodamiento amarrado debido a un uso normal. Recuerde que usted sí tiene que imaginarse que no evita no hay una tarea para evitar el modo de falla y eventualmente se amarra el rodamiento. La declaración es la siguiente, dice: el proceso se detiene. Perfecto. Sabemos que ese evento va a detener el proceso, sea un proceso de manufactura o sea un proceso de trabajo, ¿no? Que esté haciendo ese activo. Suponga que aquí dice además, esto se considera muy importante para la organización. La reparación es muy costosa. Estas declaraciones, aunque son bien intencionadas, pues son un poco vagas y no nos permiten cuantificar completamente, correctamente, el impacto que tienen estos efectos de la falla sobre la organización. Así que la declaración es vaga, estamos omitiendo información pertinente, ¿verdad? Según lo recomienda la norma, y no sabemos nada de la ocurrencia, de la seguridad, de cómo se afecta el medio ambiente, etcétera, ¿no? Si nosotros seguimos las guías de la norma nos indica que debemos, por aquí estoy señalando con el cursor, determinar cómo se detecta ese modo de falla, cómo se afecta la seguridad de las personas, cómo se afecta el medio ambiente cuando ocurre ese evento, cómo se afectaría la producción, si hay daños físicos, costos al mantenimiento, daños secundarios y un estimado de la probabilidad de ocurrencia que tendría esa falla. ¿Okay? Este sería el enfoque correcto que cumple la norma. Aquí dice que todos los aspectos del análisis de riesgo fueron considerados, tanto la parte de riesgos como la parte de costos fueron consideradas aquí. Se tomó en cuenta severidad, detectabilidad o facilidad de detección, probabilidad, etcétera, ¿verdad? Y entonces vamos a poder priorizar luego cómo atendemos esos modos de falla de acuerdo al impacto que estos tienen en la organización. Que sí que hemos cubierto las primeras 4 preguntas de las 7 del RCM y ahora pues estamos listos para gustosamente poder contestar cualquier pregunta que usted tenga sobre lo expuesto, ¿verdad? Nancy, we are ready for questions now. We have covered all the topics.
Yeah.
So
yeah, maybe you can invite people to put questions in the chat in Spanish. And then while they're doing that, I'll put up some banners. You can talk about level 1 certification and our website and that kind of thing.
Perfect. So, por favor, si tiene preguntas, vamos a poner las preguntas en el chat. Nancy las va a subir aquí a la plataforma para ya poderlas ver. ¿Okay? Cualquier pregunta que tengan, por favor, pónganla en el chat en español. Yo voy a estar leyendo las preguntas y contestándolas. Y también pues voy a estar hablando, luego de contestar las preguntas, un poco sobre el 𝗙𝗺𝗃, los exámenes del 𝗙𝗺𝗃 y demás de certificación. Vamos a ver. Let's see if we have some Spanish speakers listening to us. I see that we have 11 people watching. And I don't know if they want to learn Spanish or they speak Spanish already and they want to ask questions. So,
I'm sure it's that they speak Spanish, Jesus.
So I'm not seeing the names of these colleagues. So por favor, si tiene preguntas sobre lo expuesto, hágalas y con mucho gusto le vamos a contestar. Déjenos saber también. Let's see where our colleagues are from. Por favor, escriba por ahí en el chat, en el live, de dónde nos está escuchando. Sé que cuando estaba hablando en inglés, en the English version, I saw people from Puerto Rico. Vi algunas personas de Puerto Rico. Sé que había algunas personas de México también que pude reconocer cuando estaba haciendo la charla en inglés. No sé si ya se me fueron. Maybe they know English and already left. But I would like to see where you guys are from. Me gustaría saber de dónde son.
And Jesus, while we're waiting for any questions that there may be, we had a couple of good questions that people had asked in English. How about if I put them on the screen and you can translate them and answer that question? Because there were a couple of good ones. So let me just find it. There was, okay, this one. Maybe you can answer this one in Spanish. May translate it and then answer it.
Sí. Dice Martin que él entiende que RCM requiere mucha inversión de tiempo y de dinero, ¿okay? Que es un esfuerzo que requiere mucha inversión. La pregunta es que ¿cuánto tiempo debe tomar un análisis de RCM hecho de forma efectiva? Y también ¿cuándo vamos a percibir esos beneficios? ¿Okay? Esta fue una pregunta que hicieron en la sección de inglés. Muy inteligente la pregunta, muy relevante esta pregunta. Les contesté lo siguiente. Sí se requiere una inversión considerable, ¿verdad?, de tiempo y de esfuerzo, pero el RCM se debe aplicar a activos de alta criticidad, high criticality. Y esos activos de alta criticidad pues nos van a permitir tener digamos, un retorno de la inversión bastante rápido. Segundo es, ¿cuáles son los beneficios? Hay beneficios inmediatos que obtenemos con la aplicación del RCM. Algunos beneficios blandos, como decíamos, que es la motivación del grupo. Estamos creando grupos multidisciplinarios que van a trabajar de forma natural. Y otros beneficios que tienen que ver con el negocio, con el bottom line, con los beneficios del negocio. Por ejemplo, se va a reducir la cantidad de horas hombres que se aplican de RCM. Nancy, I'm seeing now the Spanish question popping up. So,
okay, yep, take it away.
I'm not done with this one yet.
Oh, okay.
Algunas de los beneficios, por ejemplo, reducción en la cantidad de horas hombres de mantenimiento que se aplican, reducción también en la cantidad de accidentes. I didn't mention, Nancy, the aspect about the reduction of safety, less exposure to this type of safety events. También se reduce la cantidad de accidentes porque se toman en cuenta todos esos riesgos.
Have you covered this one yet, Jesus?
No, not yet.
Okay.
It is asking if the failure mode is a cause or is a symptom. Okay, that's a philosophical one. And okay, el modo de falla, según lo define la norma 𝗙İ𝗺𝗀𝗀𝗀𝗀, es un evento a través del cual se manifiesta la falla. Depende cómo usted lo defina. Si tú defines, y si lo defines correctamente, va a ser una causa. ¿Okay? Si no lo defines correctamente, va a ser un síntoma. How about this, Nancy? And Graham, the failure mode is a cause or is a symptom? I'm saying, if you define it correctly, it's a cause. If you don't define it correctly, it's a symptom. So it depends how you define it. Así que si usted lo define correctamente, es una causa. Si no lo define correctamente, puede ser un síntoma. Okay, I have a question from, okay, Héctor Velázquez. Gracias, Héctor, por la aportación. Gracias por la pregunta. I have one from Leonardo dos Santos.
Are they in the chat? Are they in the chat, Jesus? I don't see them.
In the chat, yes. Right after Héctor, I have Leonardo dos Santos.
Oh, okay, there we go.
He posed a question in English. I think Leonardo, tell me in the chat, is Spanish your first language or Portuguese? Because I suspect that your first language is Portuguese. Maybe I'm wrong. Okay, congratulations for your question. How do you believe that big data will benefit the employing of quantitative methods for supporting scoring RPN? Okay, esta pregunta, that question is very, very common nowadays. And I will answer it in English and Spanish for the benefit of everybody.
Excellent.
So, and also Nancy and Graham, you are welcome to also contribute. So this question is really, is a trend right now. How about, using big data? How about using the latest technology? So, okay, I remember when I took my first computer class back in college, and the professor said, the definition of a computer is it's an electromagnetic box capable of doing calculations faster than humans. And the professor said, the computer will help you to do good faster and also to make mistakes faster. So if you mess it up, you know, your error will replicate like this. Okay, as an RCM practitioner, and also, I don't know if you knew, I'm a level 3 vibration analyst and instructor. I also do classes for vibration analysis. I've been doing this since 1993. So I'm up for technology, but you know, technology is good as well as it is cemented in a good platform. If RCM, you know, if we are, you know, stick to the tenets of RCM, we can use quantitative methods, we can use a predictive maintenance, whatever, you know, helps us, you know, solving, you know, the risk, lowering the risks the company is exposed to. En Spanish now. Okay, el uso de métodos cuantitativos para apoyar los RPNs. Sí, estamos de acuerdo, claro que sí. El RCM se puede beneficiar mucho de eso, siempre y cuando estemos apegados a los principios de RCM. Okay, se lo digo no solamente como instructor de RCM, sino como instructor de análisis de vibraciones y de mantenimiento predictivo, ¿verdad? Así que sí, le damos la bienvenida a estos métodos cuantitativos para apoyar los RPNs y conocer bien cuáles son los riesgos. The RPN number is an indicator of how big is the risk that, you know, this failure mode exposed the company to. So if we have data, you know, to back up our analysis, wonderful. So if we have data in which we understand the MTBFs, we understand the failure rates, perfect. I liked the comment of Carlo Odardi. Si entra basura, sale basura. Say it in Italian, Carlo. Si entra basura, sale basura.
Excellent.
Any other questions? Yes, Leonardo tells me that his first language is Portuguese. Obrigado. Obrigado, Leonardo. Meu português é muito... não é muito bom. Eu entendo português, mas não falo muito bem. Obrigado pela pergunta. I was saying that my Portuguese is kind of rusty, that I can understand more than I can speak.
Jesus, what an incredible asset, I'll use that word, to be able to speak so many languages. I would love to be multilingual. I think it's just incredible. Kudos to you.
Thank you very much.
Everyone out there who's multilingual, it's incredible.
There is a question from Elmer. 𝗙𝗵𝗁. Okay, thank you very much, Elmer. I guess that Elmer is from a pharma plant in Puerto Rico. It says, follow Martin question, RCM is addition to money and effort is very important. Yes, totally agree with you, Elmer. I will say in Spanish and English. Ok, creo que en la presentación en inglés, más que en la de español, hablamos sobre lo vital que es el apoyo a la gerencia, de la gerencia para un programa de RCM. Y los mejores proyectos que hemos hecho, los mejores resultados se han tenido cuando el esfuerzo comienza en el corporativo, en las oficinas corporativas. Y en las oficinas corporativas se van comprometiendo luego los plan managers, los gerentes de planta, y luego los gerentes de negocio, ¿verdad? Los directores de negocio y eventualmente operadores técnicos, ingenieros de campo, ¿verdad? Okay. I was telling that the best projects, RCM projects, where we get the best results are those starting at the corporate level, drilling down to plant managers, down to area managers, down to reliability engineers, operators, etc. Right? So that is.
And it all goes back to culture again, right? Jesus, where, really everyone has to buy in.
Sí. I'll say that in both languages. Uno de los problemas más comunes que tenemos es que un gerente de planta envía a una persona a un training de RCM. Dice, voy a enviar un mecánico, un ingeniero, y pretende que esa persona sola implemente RCM. Eso no va a funcionar porque tiene que venir el esfuerzo desde la alta gerencia y la alta gerencia entender los beneficios del RCM. One of the most common problems is that I've seen is sending a mechanic or an engineer to a training and pretending that that person implements RCM in a plant alone. So if the upper management doesn't understand which are the benefits, the extents of RCM, it wouldn't work. It's not going to work for that company.
Yeah.
Déjame ver si tengo algunas otras preguntas. Muchas gracias. Thank you very much, Elmer, for your question. Anything else? ¿Alguna otra pregunta?
Yep, we have a question from, two questions from Hector, or I think a question and a comment. This is the first question.
Okay. Héctor, gracias por la pregunta. El RPN sería lo mismo que tener un análisis de criticidad. Ok. Cuando utilizamos FMEA, cuando añadimos la C, es que estamos evaluando la criticidad del modo de falla. ¿Okay? Y normalmente cuando evaluamos la criticidad del modo de falla, utilizamos un método cuantitativo, se le da un peso a la severidad, a la probabilidad de ocurrencia y a la facilidad de detección. Entonces sí, el RPN viene de la palabra Risk Priority Number, y sí se tiene en cuenta esas tres cosas. Así que es un análisis de criticidad de los efectos de la falla. So Hector is asking if RPN is...
Oh, sorry.
Okay.
Sorry.
If RPM is the same as criticality analysis, I'm just telling him that when we incorporate a criticality analysis, a numeric one, we are evaluating severity, probability, and also the facility of detection, right? Detectability. The three of them together, and what we are doing is that we are assigning numbers to the failure effects evaluation. We are just assigning an RPN, and that helps a lot to understand which failure modes are of higher criticality. Eso ayuda mucho, Héctor, a entender cuáles modos de fallas tienen más peso, más criticidad.
Okay, and I'm not sure what this is, Jesus, another comment from Hector.
It's just part of the same question.
Okay. Okay, we've got a question from Vikram.
Thank you for your question, Hector. Thank you, Vikram, for your question. How do you use RCM to increase equipment reliability or staying in budget? Okay, that's a good question. Okay. How can we stay in budget if we don't tackle the failures affecting the company objectives? So here is a matter of priorities. Prioritization, for example. There is another pitfall, Nancy. There are companies that may not need RCM. I'm telling you, what kind of assets do you have? Do you have extremely critical assets? Yes, then you do RCM. Do you have high risks? Then use RCM. So the right way is to understand where a RCM is applicable, that will render a lot of value and will help the company attain goals. That's it. So yes, and here is another concept of reliability, right? We want to increase reliability, but increasing reliability for me is a byproduct, because reliability also costs. If you want to increase reliability to the sky. You don't want to have failures. If you don't want your car to fail, you can replace it every month, and you have a new car every month. You don't have failures, so meaning that you have a lot of reliability. You will never experience a failure. But that approach is too expensive. So we better say optimal reliability than maximum reliability, right? So to which extent we need the reliability to be increased. And in RCM, we are more focused on risks. We need to lower risks, okay? And we will design, let's say, a maintenance plan and other approaches as well, targeted to lowering risk. And for instance, we will get a better budget. So we will stay in budget.
Okay, we've got a question from Carlos.
Carlos Torres. Saludos a Carlos. Es un consultor que conozco. Muchas gracias por su pregunta. He visto muchas empresas que quedan atrapados en el análisis de modo de fallo. Dicen que les lleva mucho tiempo. ¿Por qué crees que el FMEA es tan complicado para muchas empresas? Interesante la pregunta. I will translate in a while. Okay. De nuevo, Carlos, es priorizar. No queremos hacer FMEA a todos. Vamos a aplicar FMEA, RCM, a los activos críticos. ¿Okay? Los activos críticos son aquellos que nos exponen, ¿verdad?, a la empresa a los mayores riesgos. El FMEA es complicado para algunas personas porque quizás no hay una comprensión, digamos, correcta, técnicamente correcta, de cómo desarrollarlo. ¿Okay? Entonces, la misma norma 𝗙İ𝗺𝗀𝗀𝗀 nos explica de qué forma podemos desarrollar el FMEA de manera que obtengamos el mayor beneficio del FMEA. El FMEA es una herramienta para medir riesgos. O sea, usted está identificando riesgos, está identificando los riesgos, los está evaluando para un eventual tratamiento. Así que priorizar es la clave aquí. Y sí, la trampa es aplicárselo a todos los activos sin discriminar criticidad. Okay? So this question, Graham and Nancy, is about the trap of many enterprises of doing failure modes across the board. And they say that it takes a lot of time. And why do you think that FMEA is so complicated for many people to do? My answer to that is follow the guidance of 𝗙İ 1011. It is not that complex. And the thing is that the companies fall in the trap of pretending to do, trying to do it to every asset. Prioritize is the key here. So it is the best way that I can answer this question. Gracias, Carlos, por tu pregunta. There is a Danny Romero from Perth, Australia.
Yep.
Yeah, I have here a comment from Carlo Odardi again. He's contributing with expanding my answer to Carlos, Carlos Torres. He says that the ability of the facilitator is a great factor here. So this is a trap also. People go to a training class and they think that they have all the capabilities to guide an RCM, let's say, effort for a company. We need a good facilitator, someone with experience. So there are three levels of, let's say, of RCM practitioners here. We have the analysts, we have the facilitators, and then we have the practitioners, right? And those practitioners are the ones with experience, implementing RCM. And these are these are the folks that we need, like leading these efforts in companies. Thank you very much, Carlos, por tu aportación. Aquí, pues, Carlos nos indica que el facilitador es crítico, ¿no? Es una persona muy importante para poder dirigir y mantenerlo dentro del presupuesto. Another question?
Oh, yep, here we go. Jesus, I remember taking driver's ed when I was 15 and a half, and I passed the class, but it was a whole different story when I got behind the wheel, right? You can learn, but doing is completely different.
Oh, yes. Yes, yeah. I agree with you. Muito obrigado. This is Leonardo from Brazil. The asset management view does consider the complete life cycle for delivering value. Do you have a recommendation for a minimum FMEA review interval aligned with this long term? Wow. Well, RCM, okay, asset management is this big, and RCM is kind of a bit smaller. But I will answer your question on the basis of RCM. Okay, people say, how often should we review an RCM analysis? And my answer to that is, there is no answer. There is no specific or correct answer to that. You should not do it every 2 months or every 1 year or every 5 years. So there is not a rule for that. There are a couple of situations under which you are going to review your analysis. First one is when the equipment ages. If you did the analysis today and in 10 years you see that your equipment ages and have new failure modes that were not considered, things like that, you should review your analysis. When you have a new technology, when your equipment now undergoes a rebuild and you have new technologies and you have now a new control system, when you have new technologies in maintenance, later in the past you were detecting gas leaks with soap, and now out of the sudden now you have ultrasound equipment to do the task. So you have to review the analysis when such things happen. But as long as you keep your operating context, as long as your failure rate is under control, you don't have to review your analysis. So whenever there is a big change, if there is a change in operating context, if there is a change in equipment condition, if there is a change in technologies, then under that circumstances is where you have to review your FMEA, your analysis. I don't know if you want to add something to that, Nancy or Graham. Do you agree?
No,
you were not in.
Yeah, I mean, there's no set time. It just really depends. Exactly what you said, Jesus.
Yeah.
Okay, en español ahora. Now we have Portuguese, Spanish, and English. Nos pregunta Leonardo que con la visión de asset management o de gestión de activos, considera todo el ciclo de vida del activo. ¿Cuándo se recomienda que el FMEA sea revisado? Entonces, yo lo contesté basado en el contexto de RCM. Usted verifica o chequea o revisa el FMEA cuando ocurren cambios significativos, sea que el equipo envejece, sea que usted tiene nuevas tecnologías, sea que ocurren fallas inesperadas, o sea que el equipo cambia de contexto operativo, usted entonces revisa el análisis de RCM, el FMEA. Si las cosas marchan bien y continúan bien, no hay un tiempo definido para estar verificando el FMEA. As long as things are okay, you continue with your FMEA. So when there are changes, significant changes, then you review it. Okay.
Okay, we've got one more question, Jesus.
We already answered Carlos' question.
I think we've done
Oh, okay, okay.
Yeah.
Again, thank you very much, Carlos, for your contribution, for your question.
Wow, well, Jesus, that was incredible. And we had some really excellent questions also.
Sí.
So, Jesus, thank you for an incredible presentation. It was really illuminating, and it's obvious that people found it very beneficial. So thank you. Maybe if I put up the banner for our next, maybe you could just, would you, Jesus, in Spanish, ask people to, if they want to be notified of our lives, to subscribe here, and then we'll put up the date of the next live event.
Yes, I'll do. Sí, por favor, hay un link aquí que está poniendo Nancy ahora para que se suscriban y reciban un aviso antes de los lives, ¿okay? Para que puedan asistir a los lives. Usted ahí entra y puede suscribirse y va a recibir notificaciones para que sepa cuándo vamos a estar dando estos lives. We're going to continue doing them periodically, every week, every 2 weeks. Lo vamos a estar haciendo cada semana o cada 2 semanas y usted va a recibir la notificación.
All right. Well, I think that'll do it. Any last thoughts, Jesus or Graham?
Oh, that's brilliant.
Yeah, excellent. Wow, we were on for a long time. That's awesome. Okay, well, thank you again, everyone. Thank you so much for joining us. Please tune in 2 weeks, Wednesday, May 19th at 9 a.m. We're going to be talking about common mistakes when identifying failure modes, the currency of physical asset management. So have a wonderful 2 weeks, everyone, and we will look forward to seeing you again soon. Bye-bye.
Adiós.